In the early years of the Second World War, German artillery moved with lightning speed. Blitzkrieg was not just tanks and aircraft, it was coordinated firepower. When panzer divisions advanced, artillery had to keep up. That urgency led to the creation of the Wespe, a clever solution built by mounting a 105mm howitzer onto the aging Panzer II chassis. It was not glamorous, it was not heavily armored, it was not built for comfort. It was built because Germany needed mobile artillery immediately, and there was no time to design something perfect. The Wespe was improvisation under pressure. At first glance, it worked. Wespe batteries could follow armored units, deploy quickly, and deliver indirect fire support during fast-moving operations on the Eastern Front. Compared to towed guns, it was a leap forward. But there was a hidden weakness beneath its battlefield efficiency. The Panzer II chassis it relied on was already obsolete. Its engine was strained, its interior was cramped, ammunition storage was limited. Every design choice reflected urgency rather than long-term planning. Germany was adapting in real time, trying to maintain momentum while fighting a war that was already stretching its industrial capacity. Across the Atlantic, the United States was watching and building. After Pearl Harbor, American industry shifted into a mode no modern nation had ever achieved before. Factories that once produced cars and refrigerators began producing tanks, trucks, and artillery in staggering numbers. But the American approach to mobile artillery was fundamentally different. Instead of modifying an outdated platform to meet an immediate crisis, engineers developed the M7 Priest as part of a broader, integrated system. The Priest carried the same 105mm caliber class of firepower as the Wespe, but it sat on a modified chassis derived from the M3 Lee, a larger, more robust vehicle designed for mass production. It had more internal space, better crew protection, and most importantly, the ability to carry significantly more ammunition on board. This meant fewer pauses, fewer vulnerable resupply moments, and longer sustained fire missions. The difference was subtle at first. Both vehicles could fire shells downrange, both could support advancing infantry and armor, but one was designed as a stopgap, the other was designed as a system component in a war expected to last years. The real divergence becomes clear when examining production philosophy. Germany built the Wespe in limited numbers, constrained by material shortages, Allied bombing, and competing demands for steel and fuel. Each vehicle represented careful allocation of scarce resources. The United States, on the other hand, embraced standardization. Parts were interchangeable, manufacturing lines were optimized for speed. If a Priest was lost, another could replace it with astonishing efficiency. Industrial depth became a weapon in itself. There is a quiet but decisive truth about artillery warfare. Dominance is not about firing the first salvo, it is about firing the last. Sustained bombardment breaks defensive lines, shatters morale, and shapes the battlefield long before infantry arrives. The Wespe could deliver sharp, effective strikes, but its limited ammunition capacity and mechanical wear meant it could not maintain prolonged pressure without frequent pauses. Every resupply exposed it to risk. Every mechanical failure reduced available firepower. Meanwhile, American artillery doctrine emphasized continuous fire coordination. Forward observers, radio networks, and logistics units were synchronized to keep guns firing. The Priest was not simply a self-propelled howitzer, it was a moving node in a vast network of trucks, depots, rail lines, and factories that stretched across an ocean. When one battery fired, another prepared. When ammunition ran low, convoys were already on the move. The battlefield saw only the shells. It did not see the industrial ocean behind them. This contrast reflects a larger shift in the war itself. Early German victories were fueled by operational brilliance and rapid adaptation,
But as the conflict expanded, it became a war of endurance. Fuel consumption skyrocketed, ammunition expenditure multiplied. Replacements were needed not just for equipment, but for trained crews. In such a war, improvisation, no matter how ingenious, faced limits. Systems backed by deep reserves did not. The Priest did not terrify German forces because of a larger gun. It did not outclass the Wespe in raw caliber. What it represented was far more significant. It represented predictability, reliability, the certainty that if one was destroyed, another would appear. It represented artillery units that could conduct longer fire missions, survive longer in combat, and absorb losses without collapsing operational tempo. By 1943 and 1944, the character of the war had changed. It was no longer about rapid breakthroughs alone. It was about sustained pressure across multiple fronts: North Africa, Italy, Western Europe. In that environment, the difference between a clever adaptation and a scalable system became decisive. Germany was still building weapons to solve immediate tactical problems. The United States was building frameworks designed to outlast the enemy entirely. The story of the Priest and the Wespe is not simply the story of two machines. It is the story of two philosophies colliding on the battlefield. One relied on ingenuity under constraint. The other relied on overwhelming coordinated production. When shells began to fall day after day without interruption, when artillery barrages resumed almost as soon as they ended, the deeper reality became impossible to ignore. World War II was evolving into a contest not just of tactics, but of output, of steel, fuel, trained crews, and replacement speed. And in that contest, the seeds of dominance were already planted long before the first shell left the barrel.
At first glance, the comparison seems almost unfair. Both the M7 Priest and the Wespe carried a 105mm howitzer. Both were open-topped. Both were designed to provide indirect fire support to advancing armored formations. On paper, their battlefield roles were nearly identical. But wars are not decided on paper. They are decided in mud, in mechanical failure, in ammunition counts, and in the endurance of the men inside the vehicles. The German Wespe was built on the modified chassis of the Panzer II, a light tank that was already becoming obsolete by 1942. Its Maybach engine pushed a vehicle that was stretched beyond its original design limits. The interior space was tight, forcing the crew to operate in cramped conditions during long fire missions. The Wespe carried roughly 32 rounds of 105mm ammunition on board. That meant every sustained barrage required careful rationing. Fire too quickly and you risked running dry at the worst possible moment. The Priest, in contrast, was built on a much larger and more stable platform derived from the American medium tank family, initially linked to the M3 Lee chassis before later variants transitioned toward the M4 Sherman line. This gave it a stronger suspension system, a more powerful radial engine, and more internal volume. That extra space mattered. The Priest could carry roughly 69 rounds of 105mm ammunition, more than double the Wespe's onboard capacity. In artillery warfare, that difference is not minor. It determines how long a battery can maintain pressure before exposing itself to resupply operations. Armor protection also told a quiet story. Neither vehicle was meant to duel tanks. Both relied on positioning behind the front lines. But the Priest's frontal armor was thicker, and its overall structure more robust. Shrapnel, counter-battery fragments, and stray machine gun fire were constant threats. A few extra millimeters of armor could mean the difference between a wounded crew and a vehicle that kept firing. Survivability extends experience. Experienced crews are more accurate, faster in deployment, and calmer under pressure. Mobility revealed another layer of contrast.
The Wespe was lighter and, under ideal conditions, agile. But the Eastern Front was rarely ideal. Mud seasons, deep snow, and broken terrain strained its lighter chassis. Mechanical breakdowns were common, especially as spare parts became scarce. The Priest, heavier and built on a sturdier suspension, handled long movements across North African deserts and Italian mountain roads with greater consistency. Reliability is not dramatic, but it wins campaigns. There was also the matter of ergonomics and workflow. The Priest's fighting compartment, though still open-topped and exposed to weather, allowed better crew coordination. Ammunition racks were more accessible, radio equipment was standardized and integrated into broader Allied communication networks. German units often displayed excellent tactical coordination, but as the war progressed, shortages of radios and trained operators reduced their flexibility. An artillery piece without reliable communication is reduced to blind firing schedules. An artillery piece integrated into a live network becomes precision pressure. Range and firepower comparisons show technical parity. Both mounted variants of the 105mm howitzer capable of delivering high explosive shells several kilometers downrange. Neither weapon dramatically outclassed the other in ballistic performance. This is where the myth often collapses. The Priest did not dominate because it fired farther or hit harder. It dominated because it could sustain its role longer, more reliably, and in greater numbers. Production quality and maintenance cycles deepened the gap. American manufacturing emphasized interchangeable parts. If a component failed, it could often be replaced quickly using standardized spares shipped in bulk. German industry, under increasing strain from Allied bombing and raw material shortages, struggled to maintain consistent output. As the war dragged on, maintaining a damaged Wespe became more complicated. Cannibalization of other vehicles for spare parts became common. Every disabled vehicle risked becoming permanent loss. Then there is the psychological dimension. Crews fight differently when they trust their machine. A vehicle prone to overheating or mechanical faults creates hesitation. A vehicle known for reliability builds confidence. American artillery doctrine encouraged rapid displacement after firing to avoid counter-battery retaliation. The Priest's mechanical endurance supported this shoot-and-scoot flexibility. The Wespe could perform similar maneuvers, but repeated strain increased wear, and field repairs were not always simple. In isolation, each of these differences seems small. A few extra shells, slightly thicker armor, a stronger suspension, better parts supply, but warfare magnifies small advantages over time. An extra 30 shells means longer barrages. Longer barrages mean greater suppression. Greater suppression means fewer enemy movements and fewer counterattacks. Multiply that across dozens of batteries, across months of campaigning, and the battlefield begins to tilt. By 1943 and 1944, the gap was no longer theoretical. Allied forces could coordinate massed artillery fire with astonishing density. Priests operated alongside towed guns, heavy artillery, and air support in synchronized waves. German units equipped with Wespes still fought with skill and determination, but they increasingly faced shortages of fuel, of shells, of spare parts, and sometimes of trained replacements. The machines themselves revealed the deeper truth. The Wespe was a smart adaptation, born from immediate necessity. It extended the life of an outdated chassis and kept German armored divisions supplied with mobile artillery at a critical moment in the war. The Priest, however, was not an adaptation. It was part of a deliberate, scalable architecture of war. It was built to function within an industrial ecosystem capable of replacing losses and sustaining fire indefinitely. When two weapons share the same caliber, the decisive factors shift away from raw firepower. They shift toward endurance, logistics, and system design. On the battlefield, the shell impact may look identical, but behind each explosion lies a chain of factories, supply depots, training programs, and replacement pipelines. And that's where the real difference between the Priest and the Wespe begins to emerge, not in the size of the gun, but in the depth of the system standing behind it.
Artillery has always been called the king of battle, but in the Second World War it became something even more powerful. It became a measure of industrial endurance. By the time Allied and German forces clashed across North Africa, Italy, and eventually Western Europe, the question was no longer which gun fired the heavier shell. The question was which army could keep firing hour after hour, day after day, without breaking its own supply chain. The true strength of the M7 Priest was not visible from the outside. Its 105mm howitzer was effective, accurate, and reliable, but so was the gun mounted on the Wespe. The difference lay in what happened after the first volley. Sustained artillery fire demands an enormous logistical backbone. Shells are heavy. A single 105mm round weighs around 15 kilograms. A battery firing sustained missions can expend hundreds of rounds in a single day. Multiply that across divisions, across fronts, across months, and the scale becomes staggering. The Priest carried roughly 69 rounds on board, more than double the Wespe's typical load. That alone allowed longer fire missions before resupply. But onboard capacity was only the beginning. Behind each Priest stood fleets of American-built trucks, standardized ammunition crates, rail systems operating across continents, and ports unloading cargo ships around the clock. The United States transformed its economy into what historians often describe as the arsenal of democracy. By 1943, American factories were producing artillery pieces, tanks, trucks, and ammunition at rates that no Axis power could match. Germany faced a different reality. Early victories had expanded its territory, but expansion stretched logistics thin. As the war intensified, Allied bombing campaigns targeted German industrial centers and transportation networks. Fuel shortages became chronic, rail lines were disrupted, factories struggled to maintain consistent output. Even when a Wespe battery performed brilliantly in combat, it depended on a supply system that was increasingly fragile. Ammunition deliveries were not always predictable, spare parts became scarce, delays turned into operational gaps. In artillery warfare, gaps are fatal. A pause in bombardment gives the enemy time to regroup, reposition, or counterattack. American doctrine emphasized continuous pressure. Forward observers, equipped with reliable radios, could call in fire adjustments quickly. Communication networks connected infantry units directly to artillery batteries. When one Priest paused to reload or reposition, another battery was already firing. The system compensated for individual limitations. This systemic resilience shaped the battlefield in subtle but decisive ways. Consider counter-battery fire, the attempt to locate and destroy enemy artillery. The side capable of firing longer and relocating faster holds the advantage. The Priest's mechanical reliability supported frequent displacement after firing missions. Trucks arrived with fresh ammunition rapidly. Damaged vehicles could often be repaired quickly due to standardized parts. If a vehicle was destroyed, production lines ensured replacements arrived within weeks, sometimes days. For German forces, replacement was a growing challenge. By late 1943 and into 1944, the Wehrmacht was fighting a multi-front war against adversaries with superior industrial depth. Replacing lost Wespes was not simply a matter of factory output. It required steel allocations, transportation capacity, and trained crews, each increasingly scarce. The result was gradual attrition. Even without dramatic battlefield defeats, artillery strength eroded over time. Another critical factor was crew survival. The Priest's slightly heavier armor and roomier compartment improved survivability against shrapnel and small arms fire.
Surviving crews accumulate experience. Experienced crews fire more accurately, reposition more efficiently, and maintain discipline under pressure. When casualties mounted, Germany often had to replace veteran artillerymen with less trained recruits. Training programs shortened as manpower shortages deepened. The quality gap widened quietly. Logistics also influenced operational tempo. Allied offensives in Italy and later in France were characterized by massive preparatory bombardments. Artillery did not fire a few ranging shots. It delivered sustained, coordinated barrages designed to suppress defenses for extended periods. The ability to maintain that intensity depended on supply predictability. American logistical planning accounted for massive ammunition expenditures. Depots stockpiled shells in advance of offensives. Transport units rehearsed delivery schedules. Redundancy was built into the system. Germany, by contrast, increasingly relied on prioritization. Ammunition was allocated carefully, sometimes rationed. Commanders faced hard decisions about where to concentrate limited firepower. In defensive battles, German artillery often remained highly effective tactically, but it could not always sustain prolonged bombardment across multiple sectors simultaneously. The strategic flexibility narrowed. This contrast reveals a deeper truth about industrial warfare. A self-propelled gun is not an isolated weapon. It is the visible tip of an economic iceberg. Steel mills, oil refineries, training schools, and shipyards all feed into its ability to function. The Priest was embedded within a global network of production and supply, stretching from American factories to European battlefields. The Wespe operated within a shrinking continental network under constant pressure from bombing and blockade. By 1944, the imbalance became increasingly visible. During major Allied operations, artillery density reached extraordinary levels. Batteries overlapped fields of fire. Communications synchronized barrages with infantry and armor movements. Even if individual German crews displayed remarkable skill and courage, they faced a reality in which opposing fire seemed endless. That perception matters. Sustained bombardment erodes morale as much as fortifications. The dominance of the Priest was not a matter of superior engineering alone. It was the embodiment of a logistical philosophy that prioritized redundancy, scalability, and endurance. Where Germany relied on efficiency and tactical precision, the United States relied on abundance and continuity. The result was not immediate collapse, but gradual suffocation. When historians analyze why certain weapons became decisive, they often focus on technical specifications. Yet the Priest's true power cannot be measured only in millimeters or horsepower. It must be measured in trainloads of ammunition, in ship convoys crossing the Atlantic, in factories operating around the clock. It must be measured in the ability to replace a destroyed vehicle without slowing the advance. In the end, artillery dominance in the Second World War was not defined by who could design a clever platform under pressure. It was defined by who could sustain fire longer than the enemy could endure it. And in that relentless arithmetic of shells, fuel, and steel, the system behind the Priest proved stronger than the system struggling to support the Wespe.
By 1943, the war had changed its character. It was no longer a conflict of sudden breakthroughs alone. It had become a grinding, multi-front struggle stretching from the deserts of North Africa to the forests of Eastern Europe. In this new phase, artillery was not simply support, it was preparation, suppression, and survival. And this was where the difference between improvisation and scale became impossible to ignore. In North Africa, Allied forces began deploying the M7 Priest in significant numbers. The desert was unforgiving. Fine sand infiltrated engines, clogged mechanisms, and wore down moving parts. Vehicles that lacked durability quickly revealed their weaknesses. The Priest, built on a robust medium tank-derived chassis, demonstrated mechanical endurance across long desert marches. It supported fast-moving armored columns while maintaining consistent fire capability.
When breakdowns occurred, spare parts were available. Recovery units and maintenance crews operated within a logistical network designed to absorb strain. German artillery units, including those equipped with the Wespe, operated under far tighter constraints. Fuel shipments across the Mediterranean were constantly threatened by Allied naval and air superiority. Replacement parts were delayed or destroyed in transit. Even when a Wespe battery performed effectively in combat, sustaining operations became increasingly difficult. Mechanical wear that might have been manageable in peacetime became critical in a theater where supply lines were fragile. The Italian campaign intensified these contrasts. Italy's mountainous terrain demanded mobility and endurance. Artillery units needed to reposition frequently along narrow roads, often under threat of air attack. The Priest's heavier suspension and reliable engine allowed it to climb difficult gradients and redeploy with consistency. Allied artillery doctrine emphasized massed fire preparation before infantry assaults against fortified German positions. Sustained bombardments became routine. That required ammunition stockpiles close to the front and transport systems capable of replenishing batteries quickly. German forces in Italy fought with determination and tactical skill. Defensive lines such as the Gustav Line were formidable. Artillery support remained effective, but ammunition shortages increasingly limited sustained fire. Wespes could deliver sharp, precise missions, but the broader logistical system struggled to maintain prolonged barrages across extended defensive fronts. Every shell expended had to be weighed against future necessity. Then came the Western Front in 1944. The Normandy landings and the subsequent breakout into France marked a turning point in industrial confrontation. Allied forces landed not just troops, but enormous quantities of equipment and supplies. Artificial harbors, vast depots, and constant convoys ensured a steady flow of ammunition. Priests operated in coordination with towed artillery, heavy guns, and air power. Fire missions were layered, overlapping, and continuous. German artillery units faced a starkly different reality. By mid-1944, Allied bombing campaigns had significantly disrupted rail networks inside Germany and occupied territories. Fuel shortages were acute. Training pipelines were strained as casualties mounted on the Eastern Front. Wespes remained capable machines, but their numbers could not be replaced at the rate losses occurred. A destroyed vehicle was not simply a tactical setback, it represented a gap that might never be fully closed. The Battle of the Bulge in late 1944 offers a revealing moment. Germany attempted one final major offensive in the West, concentrating remaining armored reserves. Artillery support was critical to the initial surprise. For a brief moment, German forces achieved operational momentum. But sustaining that momentum required fuel and ammunition at levels the collapsing logistics network could not consistently provide. As the offensive stalled, Allied artillery resumed steady fire support, backed by a supply chain that, despite winter weather, continued functioning. Scale does not always appear dramatic. It shows itself in repetition, in the ability to conduct bombardment today, tomorrow, and the day after, in the capacity to replace a lost crew with trained personnel, in the assurance that ammunition trucks will arrive when scheduled. As 1944 turned into 1945, Germany's ability to maintain such repetition diminished sharply. Allied forces, by contrast, expanded operations. On the Eastern Front, German artillery faced even greater strain. Though the Wespe had proven valuable earlier in the war, by late stages many units struggled with shortages of fuel and spare parts. Soviet offensives overwhelmed defensive positions with massed artillery of their own. Germany was fighting on too many fronts with too few resources. The flexibility that had characterized early war improvisation became constrained by material scarcity. Meanwhile, American industry continued producing equipment in vast numbers. Even as combat intensified, production lines at home remained active. The Priest symbolized this continuity. It was not the heaviest armored vehicle on the battlefield. It was not a revolutionary in design, but it could be built, shipped, deployed, repaired, and replaced with predictable efficiency. When scale meets desperation, the outcome often unfolds gradually rather than suddenly. German crews fought with skill and courage to the end. The Wespe remained tactically competent wherever fuel and ammunition allowed it to operate. But it functioned within a system that was shrinking under blockade, bombardment, and attrition. The Priest functioned within a system that was expanding. By early 1945, the imbalance was undeniable. Allied artillery superiority was not merely numerical, it was operational. Fire missions could be sustained across broad sectors without fear of exhausting reserves. Counter-battery responses were swift. Damaged equipment was replaced quickly. The tempo of bombardment rarely slackened. The confrontation between the Priest and the Wespe thus reflects more than mechanical comparison. It reflects the collision between an industrial machine accelerating towards peak output and another struggling against mounting shortages. On battlefields scarred by months of fighting, that difference shaped outcomes in ways no single engagement could fully capture. Improvisation had carried Germany far in the early years of the war, but by the final campaigns, improvisation faced an opponent defined by scale. And when sustained industrial power met a system strained by scarcity, the balance tilted decisively towards the side that could keep firing, without pause, without interruption, and without running out.
By the final year of the war, the outcome was no longer shaped by single weapons or isolated battles. It was shaped by systems. The confrontation between the M7 Priest and the Wespe reveals something larger than artillery design. It exposes the fundamental logic of industrial warfare. The question was never simply which machine was better. The real question was which nation could sustain the machinery of war longer. World War II demanded more than tactical brilliance. It demanded fuel for vehicles, steel for production, copper for shell casings, rubber for tires, food for soldiers, and training pipelines to replace casualties. Every self-propelled gun on the battlefield represented thousands of unseen workers, supply convoys crossing oceans, and factories operating day and night. The Priest was not extraordinary because of its gun, it was extraordinary because it was replaceable. Replaceability changes strategy. When commanders know that losses can be replenished, they can plan offensives with confidence. They can absorb setbacks without halting operations. They can commit artillery to sustained bombardments without fearing permanent depletion. The American war economy, by 1944, was producing artillery pieces, tanks, trucks, and ammunition in quantities that allowed exactly that kind of operational freedom. Germany faced the opposite reality. Early in the war, rapid victories masked structural limitations, but as the conflict expanded, resource shortages tightened. Oil supplies dwindled, industrial centers were targeted by bombing campaigns, transportation networks were disrupted, skilled labor became scarce as casualties mounted. In this environment, even well-designed weapons became difficult to sustain. The Wespe remained an effective self-propelled howitzer, but each destroyed unit represented a strain on a shrinking industrial base. The concept of sustained pressure becomes central here. Artillery dominance is cumulative. It is built through repetition, through the ability to conduct bombardments not just once, but continuously. The Priest supported long fire missions because it carried substantial ammunition and operated within a reliable logistics chain. More importantly, if a vehicle was lost, another would take its place.
That continuity meant experienced artillery units could maintain tempo across months of campaigning. Crew survivability also mattered in systemic terms. A slightly better protected vehicle, combined with predictable resupply and mechanical reliability, allowed crews to survive longer. Surviving crews gain expertise. Expertise increases efficiency. Efficiency reduces waste of ammunition and shortens response times. Over time, this compounds into battlefield advantage. Germany's manpower shortages forced accelerated training cycles. Replacement crews often lacked the experience of veterans lost earlier in the war. Even if the equipment remained capable, the system supporting it weakened. The broader industrial imbalance extended beyond artillery. The United States and its allies coordinated production across continents. Raw materials flowed through secure shipping lanes. Standardization simplified maintenance. Interchangeable parts reduced downtime. The priest existed within this vast architecture. It was one component among thousands, but it functioned reliably because the entire system behind it functioned. Germany, increasingly isolated and under blockade, faced strategic compression. Multi-front warfare divided resources. Emergency adaptations replaced long-term planning. Production became reactive rather than expansive. In such conditions, improvisation, no matter how ingenious, could not fully compensate for shortages of fuel, steel, and time. By 1945, Allied artillery superiority was overwhelming, not because individual guns were revolutionary, but because the system supplying them had reached peak capacity. Preparatory bombardments before offensives were massive and sustained. Counter-battery fire was swift. Ammunition expenditure reached levels unimaginable at the war's beginning. The battlefield became an arena where industrial output translated directly into explosive force. The priest symbolizes this translation of economic power into battlefield endurance. It did not dominate through dramatic innovation. It dominated because it was embedded in a structure that prioritized redundancy, continuity, and scale. The Wespe symbolizes a different reality, one of adaptation under constraint, of tactical effectiveness limited by strategic scarcity. Wars of this magnitude expose the strengths and weaknesses of national systems. Tactical ingenuity can win engagements. Operational brilliance can achieve breakthroughs. But when a conflict stretches across years and continents, the decisive factor becomes sustainability. The side that can replace losses faster than the enemy can inflict them gradually tilts the balance. The story of these two self-propelled guns ultimately becomes a story about inevitability. Not inevitability in a fatalistic sense, but in an industrial one. When one nation can produce equipment, transport it across oceans, maintain it in hostile environments, and replace it without slowing operations, it builds momentum that is difficult to reverse. World War II was decided not only in the skies over Europe or on the beaches of Normandy, but in factories, shipyards, rail hubs, and oil refineries. The artillery shell exploding on a distant hillside was the final link in a chain forged thousands of miles away. The priest carried that chain with it into battle. In the end, the dominance attributed to America's so-called forgotten masterpiece was not about a larger gun or thicker armor. It was about a system designed for endurance. When industrial scale met a resource-strained opponent, the result unfolded steadily. Guns continued firing, ammunition kept arriving, damaged vehicles were replaced, crews endured. And in a war defined by attrition, endurance was victory.